Hi. So in this video, I'm going to go over game 2 from LSAT Prep Test B. So this one isn't available on Law Hub. Yeah, I'm going to show the game briefly, and then if you want to take a screenshot, that would be a good idea, because then I'm just going to show my scrap paper, which is why I have this set up right here. So yeah, I'm going to share the document quickly. And then if you take a screenshot, we can both look at that while you also can see my scrap paper. So here it is, game 2, questions 7 to 12. Okay, so yeah, and if you want to grab question 9 as well. Okay, cool. So I'll stop sharing that and share my phone. Okay, cool. So now let's actually get into the game. I have done this game before. I really like it. I use it for teaching conditional rules in games. So yeah, I think it's a really good one. The rules are like fairly complex, at least the last two. Okay, so a park contains at most 5 of 7 kinds of trees. So that's a maximum of 5, and the total is 7. And our trees, there they are. Okay, so if we have a maximum of 5 in, okay, so that's our max. That means that we have a minimum of 2 out. Right, so at least 2 of the trees are going to be out because we have 7 total. We can't have more than 5 in. So that's the first numerical deduction that I would want to make here. Right. Then we get into the conditional rules. So if maples are in the park, then yews are not. If yews are in the park, then maples are not, would be our contrapositive. So I've reversed and negated there. The next rule is the same pattern with different players. Okay, then rule 3 gets more complex. So if yews are not in the park, then we have either laurels or oaks, but we don't have both. So we have at least one of them in, and since we can't have both, at least one of them has to be out. So really what we'd be dealing with is L in with O out, or O in with L out. Those are really the 2 options that we would get if yews are not in the park. Okay. And we do have like 2 options there. So we actually don't know for sure which one of those is going to be the case. And then when we do our contrapositive, we have to negate that term and put it at the beginning, right? So we've got either both L and O are out, right? So neither of them is in, or both of them are in. And either of those scenarios would be enough for us to conclude that yews must be in the park. Okay, so altogether, this result and the trigger cover all of the possible situations for laurels and oaks, given that each of them has the option of being in or out. So there are 4 options. They could either both be in, both be out. Laurels is in, oaks is out. Oaks is in, laurels is out. So that's the 4 options. And so if yews are out, we know we've got one of these 2 options. If we don't have one of those 2 options, that's the negation. And that would mean that, you know, they're both in or they're both out. So if yews are out, these 2 are separated. If they're together, then yews are in. Okay. All right. Next rule. If it's not the case that the park contains both laurels and oaks, so if it doesn't contain both, that means at least one of them is out. Okay, so not having both doesn't mean that we have neither of them. So it wouldn't be L is out and O is out. It would be L is out or O is out. And because or is inclusive, that includes the possibility that both of them are out, right? So we know at least one of them is out, and they could both be out, and that would also trigger the rule. So here we have, if laurels are out or oaks are out, either one of those is enough for me to know that they're not both in the park. And then I can know that both firs and spruces are in the park. And then for our contrapositive, we can just follow a rule here where we negate each term. Negating and becomes or, negating or becomes and. We already saw that with rule 3. Okay. And we've done the same thing when flipping to the other side. So if you're not already familiar with how to create contrapositives and conditional rules, then obviously this was too fast. This is, specifically for this game, and I'm going to go through all the questions. So I don't want to spend too much time on the basics of conditional reasoning. But if you're watching this and you're interested in a video specifically for that, then let me know. There are lots of other videos on that subject that other people have already made. So certainly, you can go search up on that. And if you have an LSAT book already, it will almost 100% cover that topic. But if you would like me to deal with it, then just let me know in a comment. Okay, so let's go to our first question. Okay, question 7. So this is pretty typical for the first question on an LSAT game, right? We've just got a bunch of answer choices, and we want to find the rule breakers. Okay, so write these out here on my scrap paper so I can keep track. Okay, so if maples are in, then U's need to be out, right? We can't have both of them in. So that's going to eliminate answer choice E. Okay, so rule 1 eliminated answer choice E. Rule 2, if firs are in, then pines should be out. So we shouldn't have firs and pines together. So that allows us to eliminate answer choice C. Okay. It breaks rule 2. Rule 3, so if U's are out, then we should have laurels or oaks, and not both of them, right? So one or the other. And so actually, I see both A and B are going to be eliminated by this, right? So for A, we have a problem because neither of them are in, and B, we have a problem because both of them are in. So that must mean that D is the correct answer, right? So we've got F, L, S, and Y all in, and that would mean that who's left over? So M, O, and P would be the players that are out, and we can put a big check mark by this, which puts it into our bank of acceptable solutions, and that might come in handy later on. As we create more acceptable solutions, we'll add them to that bank. And when I say add them to the bank, I don't necessarily mean that you have to put them in this specific space on your scrap paper. You could definitely just do what I do, which is just put a big check mark next to it. And then when I'm looking to see, have I already created a bunch of acceptable solutions, I'm just looking for big check marks. And if I create something that doesn't work, I usually scribble it out. That's what works best for me, because then I'm not going to get confused and think that that was an acceptable solution. Okay, all right, so question 8. We get a question specific condition. So if neither maples nor spruces are in the park, right? So if we don't have maples and, okay, so neither nor is not A and not B. Neither maples nor spruces, so not M and not S, are in the park, then which of the following could be true? All right, so not having maples in the park is not a trigger. It's a result or a consequence up in rule 1, but I actually can't come to any deductions based on this. So that's like a trap, basically. So we don't want to deal with that one. And then spruces, if spruces are out, that means both laurels and oaks are in. Okay, so I've got laurels and I've got oaks. If I have both laurels and oaks, then I know that U's are in. So actually, if you'd misunderstood this as a trigger, you'd probably also have put U's in just for the wrong reason. But that's not a problem. So, okay, so we've got laurels, oaks, and U's. Having U's in puts maples out. Maples are already out. So the only players left over are firs and pines, and they are the subject of rule 2. So we can't have both of them in. We could actually have both of them out. So putting one of them in triggers the other one to be out. So at least one of them does have to be out, but they could both be out and that wouldn't break a rule. So yeah, so our options would be L, O, Y, and F, right? With P, M, and S out. PMS, okay. L, O, Y, and P with F, M, and S out, or just L, O, and Y with those 4 all out. So all of these are acceptable, and that means that A is the correct answer. So that could be true. Right, I'm going to some more scrap paper going here. And actually, I will probably bring this up a little bit so that you can see more. I don't know if that's really that helpful. Okay, all right, that'll work. So, all right, so which one of the following could be true? Just like a global could be true question for number 9. Right, so could we have neither firs nor laurels? That's going to be a problem because of rule 4. So if we don't have firs, we have to have laurels. And if we don't have laurels, we have to have firs. So yeah, that's just not going to work. So A is out. So here I'm doing process of elimination. Yeah, there's really, I could look to my acceptable solutions for this and see if I've already created one that's acceptable, but because there are 4 here that are unacceptable, I'd rather just do process of elimination and just go through and apply the rules. So B, we can't, so here this would be no laurels, no oaks, no U's. If we don't have laurels and we don't have oaks, then we have to have U's. If we don't have U's, we have to have one of these guys. So that's not going to work either. So basically, all of the incorrect answers here, they're going to contradict the rules in some way, right? So the consequences of having one of these players out is going to push the other one in. C, neither laurels nor spruces. Okay, so this is the same issue that we had with A, except with spruces now, but there's the same relationship exists between laurels and firs as does between laurels and spruces. So I could show the rule. So that's breaking rule 3, those 2 break rule 4. D, neither maples nor yews are in the park. So this actually is testing to see if you correctly understand how to interpret Rule 1. And the correct interpretation of Rule 1 is at least one of them has to be out, but there's no reason that we couldn't have both of them out. So yeah, that's got to be the correct answer. Since we did process elimination, we might as well finish it off, make sure that E is not possible. So neither oaks nor spruces are in the park, and we've got another one that breaks Rule 4. All right, so yeah, D is consistent with Rule 1, whereas these guys all, yeah, they broke a rule. All right, 10. What do we have for 10? Another question specific condition. So if furs are not in the park, and we'd want to follow that through. So if we don't have furs, that's going to trigger Rule 4. Remember, it does not trigger Rule 2. So we're just looking on the trigger side. So no furs means that we have to have laurels and oaks. If we have both laurels and oaks, then we have to have yews. And if we have yews, then we can't have maples. And the remaining players are spruces and pines. Because firs are out, there's no reason that we couldn't have pines, but we also don't have to have them. And for spruces, yeah, we've already worked through all of the consequences. So those are our options. What we are looking for, though, is something that must be true, and A must be true. Maples are not in the park. 11, if pines are in the park. So if pines are in, then firs are out, right? We already did the work for that. So now we just know that pines are in, and spruces are the only ones that are up in the air and that we're still unsure about. So we can just use the work that we did in the previous question. So if pines are in, firs are out. If firs are out, then laurels and oaks are in, yews are in, maples are out, and spruces are unknown. All right, so again, it's asking what must be true. So do we have to have exactly 4 kinds? No, we could, right? We could have spruces out, and that would be 4, but we could also have 5 kinds. We could put spruces in, and then we'd have 5. So A and B are both out because we don't know where to put spruces yet. So we can eliminate both of those. Both of those are possible. Neither of them has to be true. C, neither firs nor maples are in the park. So that absolutely must be true, right? No firs and also no maples. So C is the correct answer. And last question. Each of the following could be an accurate partial list of the kinds of trees in the park, except. So this one is like a little bit like our typical first question with 2 differences. So it's an except question, right? So we're not looking for what's possible, we're looking for what's impossible, and we're looking for a partial rather than a complete list. Yeah, so we're looking for something that's going to break the rules with these guys being together. So this is actually where our bank of acceptable solutions finally comes in handy. So if we have an example of oaks and spruces being together, then we can eliminate A because we know it's possible. So here we're eliminating 4 things that could be true in order to find the exception. So yeah, so A, oaks and spruces being together, we have an example of that from 10 and 11. It was totally possible to put oaks and spruces together. So A is out. B, oaks and yews. I mean, those guys have been together in a bunch of our acceptable solutions. C, firs, laurels, and oaks. We have an example of that right down here. Firs, maples, and oaks. So I don't think we've had a single solution where maples are in, but we can give it a try. Okay, so firs, maples, and oaks. All right, if firs are in, then pines are out. And that's as far as we can go with that. If maples are in, then yews are out. But that's also a trigger, excuse me. So if yews are out, then we have to have L or O in. Okay, we have O in, and the other one has to be out. So L would have to be out. And if L is out, then firs and spruces have to be in. We already have firs in, we can add spruces. That's actually not a problem here, remember, because this is a partial list. So the fact that this wasn't mentioned isn't fatal to this scenario, right? Like we could just add that and it's not a problem. Nothing contradicts here. So D is out, which means E must be the correct answer. And let's find out why E doesn't work. We've got laurels, maples, and oaks. So they've been tricky here, and they put maples in between laurels and oaks. But we know that if both laurels and oaks are in, then yews should be in, and that's the thing that has been consistently triggering maples to be out, right? So there we have a problem. If maples are in, then yews should be out, but if laurels and oaks are in, then yews should be in. So these two would push yews in, and this one would push yews out. We have a contradiction there, so E is just not going to work, even as a partial list. There's no way to save it. Yeah, so that's it for this game. If you have any questions, just leave a comment below, and also feel free to let me know if there are other games that you'd like me to go over. Okay, have a good one. Bye.